Okay, so what we're going to shift into now is parabolas, okay, or sometimes called quadratics. Quadratics, that means it's a second power, so it's something to the second power, and then the shape it makes is actually called a parabola. So these little guys here, it looks like a U or an upside down U. That's a parabola, okay? Awesome. So we are going to observe the following on each one of these. We do have a puzzle piece coming on this today because this will be pretty quick. It's pretty straightforward. So first of all, we're just going to do this based on the graph, okay? If you look at the next few pages of notes down here that we're going to do later on this week, we're going to be drawing our own graph. But for now, we're just going to look at the graph and analyze it, okay? Okay, so it doesn't go in this order, but I always think that the most important point on the parabola is the vertex, okay? The vertex is like the center of the parabola. It's the turning point of the parabola, where it either switches from decreasing to increasing or from increasing to decreasing. And so I'm going to look at that first. That's called the vertex. So on this one, it is right there. So you can draw a dot right there, kind of at the low point on the graph. And that is our vertex, okay? So the vertex is a coordinate point. So the coordinate point for this one would be 1, -9, okay? So that's our vertex. 1, -9. You see how I'd call that kind of the center point of the graph? It's like where it turns, okay? It was going down and then it switches and now it's going up, okay? All right, now the line of symmetry is actually an imaginary line that goes right through the vertex. It's a vertical line. So it is right here. And symmetry means it's the same on the left and the right. For any of you who have like an art background, I know a lot of times in art they talk about symmetry. This side looks like that side. It's like you could fold the piece of paper over that dashed line, and the two sides of the graph would match up. Okay. Now the line of symmetry is always written as x equals a number. And what that number is it's always the x value of the vertex. So that's kind of like why I like to do the vertex first on this, is because once I have the vertex, then I can see where that line of symmetry is because it goes right through it, okay? Okay, next up, x-intercepts. X-intercepts is where it hits the x-axis. And so on this one, I can see very clearly here. Sometimes it's not as clear, but on this one it is. I have 2 x-intercepts. That's actually pretty common with these ones, these parabolas. We have 2 x-intercepts. And so I'm going to say we have x-intercepts at -2 and +4. That's the 2 spots where the graph hits the x-axis. All right, y-intercept is where it hits the y-axis. So I see that we do have a y-intercept right here at -8. Okay. Direction. This is either opens up or opens down. I think this one's pretty easy. I think these are all pretty easy to see for that question. So on this one, it opens up. Okay, next up, the min or the max value. Okay, so I'm actually going to erase all these points now so we could take a look back at the graph. You don't have to do that if you did, but I'm going to go ahead and do that because it's easy for me to do on my computer here. So we're going to look at this graph and we're going to analyze, does it have a minimum or a maximum value? Okay, every graph only has one of those two. It doesn't have both. I'm going to argue that this one has a minimum value. If you look at low to high, these arrows mean that this graph goes up forever, okay? So it has no maximum value. It keeps going up and up and up and up. But the graph never gets lower than the vertex right there, correct? That's the lowest point on the graph. So I'm going to say here that it's a min value, a minimum value. And the minimum value here is going to be -9. The min or the max value will always be the y value of the vertex. Because like we said, it's like low or high. So that's why we're talking about the y value, right? Because it's the y value tells you how low or high something is. So I'm going to say this one never has a y value that's lower than -9. There's nowhere on this graph that goes below -9. So that's my minimum value, okay? Okay, let's do one more together here, and then you can try the last one on your own. So for this one, I got my vertex right here. So that point is going to be 2, 0. Remember, it's x, y, right? So it's a 2 and then a 0. All right, so then my line of symmetry would be at x equals 2, because it's always x equals the x value of the vertex. That's that imaginary dashed line that kind of cuts the graph perfectly in half. Okay, x-intercepts, well, actually, this one only has one x-intercept. It's at x equals 2. So the vertex happens to be the only x-intercept there. That's the only time it hits the x-axis, is that one time. I said a lot of times these graphs have 2 x-intercepts. Sometimes they have 1, and sometimes they have 0. Sometimes they don't hit the x-axis at all. All right, looks like I do have a y-intercept here at -4. You got to be careful on this one because the scale is counting by 2 on the y-axis. So I'm going to say y equals -4. My y-intercept. All right, the direction, it clearly opens down. And then lastly, is it a min or a max value? So I look at the graph. The vertex, I would say, is the highest point on this graph, correct? It never goes higher than the vertex. So that's actually because it's opening down. And so I'm going to say that this is a max value. And the max value is the y value of the vertex. The max value in this case would be 0. There are no y values on this graph higher than 0. You may be thinking 0 is not a very big number. How can that be our max number? Well, if you look at all the other points on the graph, they're all negative. So 0 actually is the highest it ever gets to, okay? All right, so then last up, let's go ahead and do this last one. Why don't I give you guys 2 minutes here to do this one. Be careful again on the y scale on this one. It looks like it's counting by 2s on the y scale. All right, so I did get -4, 6 for my vertex. Like I said, you got to be careful about that y scale. It was counting by 2s. So that would mean my axis of symmetry, or my line of symmetry, is x equals -4. Trick question for x-intercepts here. I'm going to say none. And I did say last time that that's possible. If you put, I don't know, NA or, yeah, they're not there, whatever. There's no x-intercepts. Y-intercept looks like it's up here at 22. This one opens up, which means the vertex is the minimum value. So the smallest y value on this graph is 6. Every other y value on the graph is higher than 6, so 6 is the minimum value, okay? Pretty simple, pretty straightforward so far, correct? Okay, so I just want to make sure we really understand this before we move on, okay? Okay, so what we're going to do next, actually, hold on, let me...